Hi everyone, welcome to my channel. In this video I'm going to explain the definition of terms of one-to-one function and an onto function. Now let's start with the one-to-one function. What is a one-to-one function? A one-to-one function, also known as an injective function, also known as what? An injective function, is a function where different inputs gives different output such that A is not equal to B. Then we have that function of A is not equal to the function of B. That means no two different elements in the domain share the same output. We will have an example here. Example. This is an example. We have that fx is equals to 2x plus 1. Fx is equals to 2x plus 1. Now let's substitute the values of 1, 2, and 3 into this function. We have f1 is equals to 2 into 1 plus 1. We have 2 plus 1, which is equals to 3. We have here f2, which is equals to 2, open bracket 2 plus 1, which is equals to 4 plus 1, which is equals to 5. We have here f3, which is equals to 2, open bracket 3 plus 1, which is equals to 6 plus 1, which is equals to 7. We have here f4, which is equals to 2, 4 plus 1, which is equals to 8 plus 1, which is equals to 9. Now, you can now see here that 3, 5, 7, and 9 is the range. That is the output. 1, 2, 3, and 4 is the domain or the input. So the ordered pair is going to be 1, 3, 2, 5, 3, 7, 4, 9. Now, you can see here that in this first ordered pair, 1 is the input, has an output of 3. 2 is the input, in this particular part has an output of 5. 3 here is an input having an output of 7, and 4 here having its own different output. You can see here that there is no part in this set of ordered pairs where an input have the same output. For example, now if 1 had an output of 5 and 2 here had an output of 5, it would have been called a non-one-to-one function. Why? Because in a one-to-one function, each input should have their own separate output. Mr. A marries Mr. B. Mr. C can't marry Mr. B. Let's group this as A, B, C, D, E, F, G, H. Now, as A marries B, as this alphabet are different, A marries B, C cannot marry B, instead marries D. The same thing with E and F, G and H. Now, for example, we can have a function like f is a function from A to B, which is f is a function. Here the domain is given already. The domain will be 1, 2, and 3. 2. Then the codomain will be 2, 4, 6, 8. Now, what is the ordered pair? The ordered pair will be 1, 2, 1, 2, and then the next one is going to be 2, 4. The next one is going to be 3, 6. Next one is going to be 3, 6. Now, in a one-to-one function, every input must have different outputs. No input can have two other outputs. It must have just one input. So now, in that case, we know that this is the codomain. We know that this is the codomain and this is the domain. Well, this set of values here, as I explained in my previous videos, are the range. Well, we know here that 1, 2, and 3, which we know that is the domain, as I already stated here. Now you can now see that each input must have only one output. That is what is called a one-to-one function. That is why it is called a one-to-one function. We'll now be looking at the onto function, also called the surjective function. Now, the definition of the term onto function is that an onto function, also called the surjective function, is a function where elements in the codomain has at least one element from the domain mapping to it. If we know the definition of terms of a domain, a codomain, and a range, as I explained in my previous videos, you are going to understand the definition I'm giving you right now. But let's move into solving to prove that which I just said. Example 1. Example 1. Here we have that fx is equals to x plus 1. Here a, which is the domain, is equals to 1, 2, 3. These are the values we insert here. So now, when we now insert these values into this function, inserting 1, we have 2. Inserting 2, we have 2 plus 1, 3. Inserting 3, we have 3 plus 1, 4. Now, for the ordered p, we have 1, 2, 2, 3, and then 3, 4. 1, 2, 2, 3, 3, 4. Now, we now know that the domain, this is the domain, this is the codomain. Now, these values here, 2, 3, 4, is a range. The values that are involved in the ordered p is a range, 2, 3, 4. Now we see that range is equals to what? 2, 3, 4. Now, you've noticed there are two things you should notice here. Number 1, you notice that the range is equal to the codomain. Now, number 2, we notice that this is an onto function. Why is it an onto function? Because every element in the codomain is involved when forming the ordered p. I said earlier that an onto function, also called the surjective function, is a function where every element in the codomain has at least one element from the domain mapping to it. You can see here that in the codomain, that 1 maps to 2, 2 maps to 3, 3 maps to 4. Every element in the domain maps to all the elements in the codomain. So this is an onto function. This is an onto function. Now we have example 2. Example 2, in the question we have, let's if as a function coming from A to B. This is the domain and this is the codomain. Now we have the function of 1 is equals to A. The function of 2 is equals to A. The function of 3 is equals to B. We can also see the function of 1 is equals to A. The function of 2 equals to, okay, that can still be the same thing. Let me not go further. Now, this is the ordered p. This is the ordered p. Now, in this ordered p, we have that 1 maps to A, 2 maps to A, and 3 maps to B. This explains why the function of 1 is A, function of 1 A, function of 2 B, A, and function of 3 B. Now, you can now see that had it been it was supposed to be a one-to-one function. Now, in a one-to-one function, an output cannot be shared by two different outputs, two different inputs. One input will have its own different output. Another input will have its own different output. In this case, if this was to be a woman and if this was to be a woman, this woman married two men, that is 1 and 2. But in a one-to-one function, I repeat, in a one-to-one function, every man marries his wife. No woman is married to two different men. But you can see in an onto function, everybody must be carried along. You can see here that in the domain, we have 3 values. In the codomain, we have 2 values. But the law of an onto function is that nothing will be left behind. Now, another thing you should note about an onto function is that every element are being carried along. I already said that earlier. So this is an onto function. This is an onto function. Now let's take the number 3. Let's say fx is equals to 2x. We can be asked a question: is this function a one-to-one function or an onto function? Now let's prove that. A, we take the domain 1, 2, and 3. B, the codomain will be 2, 4, and 6. Once you input these values here, you have these values. Now, the ordered pair is equals to 1, 2, 2, 4, 3, 6. Now, you can now see that every element in B is used. Every element in B is used. So, therefore, I will say therefore, function of x, which is equals to 2x, is an onto function. Therefore, function of x, which is equals to 2x, is an onto function. Now, we'll be looking at what we call a bijective function, a situation where a function is both a one-to-one function and an onto function is called a bijective function. Now, let's give an example. If fx is equals to x plus 1. Now, if we have a domain of 1, we are going to have 2. If we have a domain of 2, we are going to have 3. If we have a domain of 3, we are going to have what we call 4. Now, the ordered pair is 1, 2, 2, 3, 3, 4. 1, 2, 2, 3, 3, 4. Now, you can now see, I said earlier that in a one-to-one function, every input has its own different output. Every man marries different wives. Now, but that's true. You can see that this is a one-to-one function. But in an onto function, you can see that every element are being carried along. Let me explain that. We already know how we got these values. The domain, and here the domain, and here the codomain. The codomain or the range. The codomain, here is the codomain. A is usually the domain and B is usually the codomain. A domain, B codomain. Now, you can now see here in the codomain that every element is carried along. Nothing is left behind. Every element is carried along. So, in a case where every element are being carried along, this is also an onto function. So, in that case, this is called a bijective function. If you found my video very helpful, do well to like, subscribe, share, and comment. Thank you very much.